welcome to another interactive science lesson with me, Lara from Theatre of Science. Today we are going to make jam tarts and talk about the science of all kinds of things. Let's get going. Weigh out 200 grams of flour. Now if you saw my gravity lesson and you're really on the ball, you might be able to spot the first bit of science we're going to talk about. Because I just said weigh out 200 grams and a physicist would say that that was totally wrong. When you've done 200 grams of flour, put 100 grams of butter into the same bowl. Look at that, almost spot on. A tiny bit more. Why is weigh out 200 grams wrong? It's a GCSE question again, I'm always asking you those. Mass is measured in kilograms, not weight. Mass is measured in kilograms. Mass tells you how much stuff there is in your body. And weight tells you by how much force you're being pulled down to the ground. Exactly, Anna, exactly. So the way that we always talk about it is, mass is how much stuff is in you. So if you've got 1 kilogram bag of sugar on Earth, that's how much stuff is in the sugar. So if you put that bag of sugar on the moon, there'd still be 1 kilogram of sugar on the moon. Weight has to do with the force of gravity. We'll say for today that weight is how much you're being pulled to Earth, and weight is something to do with mass. To calculate your weight, you work out mass times little g. It's the acceleration due to gravity. It's like how strong gravity is on any planet. G on Earth is 9.8, because I know some of you are going to want to know that, but we'll call it 10. Hello, Emily and Isabel. Hello. Oh, it's so exciting to see you in my kitchen. Hi. So if you calculate the weight of this kilogram of sugar, on Earth it would be 1 times 10, because 10 on Earth, G is 10. So you would say the unit of force is the Newton. So you would say that the weight of that bag of sugar on Earth is 1 kilogram times 10. Whereas on the moon, G is only 1.6. We've talked in our gravity lesson about how the smaller something is, the less gravity it has. So on Earth it's 10. On the moon it's 1.6. So the weight of that bag of sugar on the moon would be 1.6 newtons. So you can see my scales here. The scales work because you put something heavy on them, don't they? And then a little needle moves back and forwards. Is this scale working out the mass, or is it working out the weight? Caitlin, excited? What are these scales working out, the mass or the weight? It's the weight, isn't it? Because the bowl is being pushed down to the ground and the scale is measuring how much of a pushing force it's feeling. So really, it's fine. It's just, in physics, the difference between weight and mass is important. Right, that's all the weighing we've got to do. That's good, isn't it? So now we are at the rubbing in stage. So this is rubbing in, okay? You have to, just do what I'm doing. Just rub it in. So why are we rubbing in, right? It's all to do with gluten. Now, if you'd asked me last week what gluten is, I would have said delicious. But I know more now. Flour has got stringy proteins in it, okay? Little molecules, particles, proteins that are called glutenin and gliadin. And when flour gets wet, those two proteins combine and they kind of unfold and then bond together in a very big tangle. So when you knead bread, what you're doing is you're making all the strands of gluten kind of line up next to each other, and this forms a web, and that web is really good at trapping air. That's why bread rises, because you've made a beautiful glutinous web, and all the air that comes out of the bread sort of gets trapped. Different types of flour have different amounts of protein. So bread flour has loads of protein in it so that you get loads of gluten, so you get that nice web. But pastry flour, hopefully the flour that we're using, doesn't have very much protein in it, because we're not making bread. We want the opposite of loads of gluten. We don't want this pastry to be chewy. We want it to be like crumbly and melty and all lovely like that, flaky. So we don't want our flour particles, we don't want our gluten strands to bond together. So what you're actually doing when you rub in is you're coating the little particles of flour with butter. You're kind of giving them like a little waterproof coat. You remember I said that when flour gets wet, that's when the gluten like unravels and forms. So you're giving your flour particles a little waterproof coat so that the gluten can't all like stick together. How good is that? so you don't get any knots of gluten. But this is the nightmare, isn't it, with pastry? Because if the flour is too well coated and you give it too good a waterproof coat, then the particles don't stick together at all, and then your jam tarts fall apart and your pastry is like really difficult to work with. So yeah, I don't know, we'll see how this goes. That's why you're supposed to have everything very cold when you make pastry, because you don't want the butter to melt, because then the butter coats the flour really, really well and it'll all fall apart. So I am incredibly sweaty, as you've probably noticed, so because it's very hot today, isn't it? So we'll just see how it goes. But this is about science. We're exercising our brains, aren't we? We're not after the perfect jam tart. It's going to taste good. It's just fat and sugar, isn't it? Right. Now we are going to add the water. As little water as possible, because don't forget, we don't want the flour to get too wet, because we don't want those gluten strands to form and make our bread chewy. Don't do what I'm about to do while you're baking, which is touch your hair. Oh yeah, conditioning buttery flour, but that was really going to annoy me. So I've got some water here. We're going to stir it with a knife again, because we don't want to be like creaming our mixture. We just want to touch it as little as possible. So with bread you want as much water as possible, but yeah, with pastry you want as little water as possible. This is why, if you're a total pro... Oh, hello Molly, are you doing this? If you're a total pro, you might be using half lard and half butter, because lard hasn't got any water in it. Butter does have some water in it. Butter is about 15% water. So if you want a really nice dry pastry mixer, use a bit of lard, but lard doesn't taste nice. Plus, if you're a vegetarian, you might not want to eat fat from an animal. So it's up to you. I'm just using margarine. What we're going to do now is put that in the fridge. Put that in the fridge, but just keep a little bit, and we'll have a little play with this while that's chilling in the fridge. So we're going to put it in the fridge so that the gluten strands relax and our jam tarts don't shrink in the oven. We're going to have a little pressure lesson now. So, get your dough, get a bit of extra flour so that it doesn't stick to the table. There we go. Give it a little roll, I suppose. You might want to eat this afterwards, but hopefully it won't taste very nice if our experiment works. Okay, so roll that out a bit. And then what I'd like you to do is just get the palm of your hand and press it down onto the pastry. Pretty firmly. There we go. So you can see with mine, nothing very much has happened. And now get your finger, poke it into the middle. And as you can see, it's made a bit of a dent. Isaac, Kevin, what would I do without you? Yeah, get your ovens on. What did I say? About 180 degrees. 180 degrees C. Let's do that. Thanks, Kevin and Isaac. Okay. It's getting excited by my pressure lesson. Yeah, so you could try that again. Like maybe try just with a few fingers. Push down with a few fingers. And then press down with one finger. And you can see there that where I've just pushed with one finger, it's made more of a dent. That's the group of fingers, and that's one finger. Why is that? Because pressure equals force divided by area, which means that the bigger the force, the bigger the pressure on an object, and the smaller the area, the bigger a pressure on an object. You can imagine that this is the number of sweets you get. So if you've got loads of sweets and you're sharing them out between loads of people, you don't get many sweets. If you've got loads of sweets and you're sharing them out between a small amount of people, you get more sweets. So, yeah, pressure is a measure of how much force per area is pushing down on something. Izzy says it's because the pressure is spread over the surface. Nice one, Izzy, exactly. You'll like this. I've done a little puzzle for you down here. This is roughly the size of the foot of my 2-year-old. She weighs 12 kilograms. I'm saying that her foot is about 11 centimetres long. To be proper, we'll call it 0.11 metres. And I think her foot is about 5 centimetres wide. My husband weighs 75 kilograms. His foot is 30 centimetres long, 0.3 metres, and about 0.12 metres wide. Okay, so let's work out, if they stand on my foot, how much does it hurt? How much pressure do both of them put on my foot? Okay, so first of all, good practice for your GCSEs, you write out your equation. Pressure is force divided by area. So, let's work out the force first. Well, we learned earlier, didn't we, that force is mass times little g, and both my 2-year-old and my husband live on Earth, so g equals 10. So, for my daughter, the equation is 12 times 10, and for my husband, it's 75 times 10. So the force that they're pushing down with is 120 newtons for my daughter and 750 newtons for my husband. So that's what you'd expect, isn't it? That a bigger, heavier person would be pushing down with more force. Okay, but force is pressure divided by area. So if we want to find the pressure, we've got force, we need to find area. Let's work out the area then. So if you've done maths, hopefully you know that, like, if you're working out the area of a rectangle, you do this times this. So obviously the foot isn't a perfect rectangle, but we'll say that it's this times this to find the whole area of the foot. So the area of my daughter's foot is 0.11 metres times 0.05 metres, and that's the area of my husband's foot. And so again, as you'd expect, slightly weird numbers because I've done it in metres, but you can see that the area of my daughter's foot is a lot smaller than the area of my husband's foot. That's a bigger number than that one. So let's put all those together and work out the pressure. Pressure equals force divided by area. So we'll do that divided by that, and we'll do that divided by that. Ready? What? So pressure is measured in pascals, PA. So look! Isn't that weird? That verifies exactly what I thought, that even though my daughter weighs a lot less than my husband's, because her feet are a lot smaller and pressure is the amount of force per unit area, she is putting a force of 21,819 pascals. She's putting that much pressure on my foot when she steps on my foot, and my husband's actually putting a little bit less pressure, only 20,833. And that's why when my 2-year-old comes over in her wellies to give me a lovely big hug and steps on my foot, it really hurts, because it's like my husband doing it, but even more. Is he? You guessed right. Yeah, well done. Good. Right, I think it's probably okay to get our pastry out of the fridge now. Or it'll have to be, won't it? Like I say, we're not supposed to knead our pastry because we don't want the gluten strands to develop. But what I thought would be quite interesting was if we did knead a bit of the pastry. Take that little bit that you did your experiment on and give it a good hard knead. Just like, do it all wrong. I've always wanted to do this. Just mush up your pastry so much, like roll it into a ball, scrunch it, and we'll put that in the oven as well, and we'll see if it's true that if you knead pastry and you get the gluten strands all lined up and working, that your pastry doesn't taste very nice and tastes really chewy. Hi, Elsa's mum. She wants me to tell you she has pastry all over her hand so can't type. Excellent. Well done, Elsa. That's exactly what I wanted. Yeah, for you to get stuck in. Okay. So that's my sweaty little bit of pastry gone wrong. You can taste that later. Let's try and do it properly now. So a bit more flour on your surface. Get your rolling pin or your wine bottle. Flour your rolling pin so that it doesn't stick to the pastry. And give it a little roll. Oh, it's looking alright though. Any baking experts out there? Roll it out to about ½ centimetre. And then the other thing you need to do is get your Yorkshire pudding tin and give it a good grease. Your oven, Linda, hello Linda, your oven wants to be at 180 degrees. And that's because it would actually be better to have your oven really hot. I'm greasing my tin now, by the way. For the pastry, it would be better to have the oven really hot because that would dry the gluten strands out really fast and make your pastry nice and flaky. But that would also make your sugar in your jam incredibly hot, incredibly fast, and your jam would boil over. But if you have your oven too cool, then your jam doesn't boil over, but the butter melts really slowly before the gluten strands are formed, and you get soggy bottom. So it's a balance. So the short answer is 180. Yeah. Those are greased. Now, you maybe got a biscuit cutter. I'm just using this glass. Ooh. Let's cut a few rounds of pastry. Just get on with it, Lara. You know what we're going to do once these are in the oven? Anyone think about how we kill a few minutes during a theatre of science lesson? Oh, I think I've done mine far too thick, guys, but never mind. Just putting these into my Yorkshire pudding tin. Exactly! Yes, Anna and Ella from Leeds. And... oh yeah, Izzy. Yeah, story time. Story time begins with a significant period of history for France. It's the late 1700s France. If anyone knows what that is. What happened in France about 240 years ago? And how does it relate to jam tarts? So I've made my pastry too thick, but I'm going to have to make it all too thick now, because if I have some thick and some thin, the thin ones are going to cook too fast. So I'm just going to stick with it. There we go. Oh, Anna's got it, yes. Let them eat jam tarts. You know what happened in France in the late 1700s. You do well to be able to relate it to jam in particular. Yesterday you made banana bread, tray baking cupcakes. Oh, I need a banana bread recipe. My bananas are disgusting. Not a euphemism, my bananas are really gross. Right, make one. What do you do with this last little bit of pastry, everyone, eh? I'm just going to pop it in. And I'm going to put my poor little needed sacrificial bit of pastry in there. Boop, there we go. Should we put the jam in? Why not? So I actually made this jam the other day because we've got loads and loads and loads of blackberries in our garden, and I'm going to show you. I had to take all the seeds out because my children are terrible and don't eat anything with bits in, but I did suddenly realise I could maybe use the seeds to show you a bit about the Milky Way galaxy. So jam is a bit crazy. You know, they've done some experiments and they've worked out that sugar doesn't actually melt. It just kind of, what's the word they use? It's like degrades. So in the same way that like cardboard doesn't melt, sugar doesn't really melt. If you heat it up fast, it'll boil in a different way than if you heat it up slow. What I'm really saying is, don't put too much jam in your jam tarts. Don't put in as much as you think you should put in. I'm doing that thing where I put the right amount of jam in and then I panicked that I wanted more jam and now I'm topping it up. Don't do that. Just leave them alone. It's the second time I've got to eat jam in one of these lessons. Right. Get rid of that bit. Oops, made it worse. Let's put those in the oven. There we go. Yeah, what are we going to do while those bake? Shall we do story time? So, jam tart story time. It is about 240 years ago in France. Rich people make up a very small percentage of the population, but they have a lot of control over who gets into power. Poorer people make up a huge percentage of the population, but they don't have very much control over the country. Times are getting hard, the weather's been bad, there's not much to eat, and poor people are starting to feel pretty badly done by. Someone goes to the royal family and says, the poor people, they don't have any bread to eat. And the king's wife, who is called Marie Antoinette, is actually very sympathetic to the plight of the common man, gives a lot to charity and feels really bad about it. But that's not a very good story. So history tells you now that Marie Antoinette said, they don't have any bread to eat, I will let them eat cake. The divide between the rich people and the poor people gets greater and greater and greater. Eventually, the poorer people storm the fortress at Bastille and nick a load of weapons. Bastille Day is still a national holiday in France. You still get the day off to celebrate the fact that people got hold of these weapons. And over the next few years, until about 1795, I can't sugarcoat it for you guys, it's kind of a bloodbath. Rich people and people who have unpopular jobs like tax collectors, they're basically hunted down. Just terrible. I mean, some people would say that I'm making light of it here, but it's a very, very dark period of French history. After this period, which is called the French Revolution, the person in charge is Napoleon Bonaparte. Now, he's got a problem because he's trying to invade everyone, basically, and he keeps getting stopped by the fact that he doesn't know how to keep food fresh. Russia basically just retreat, because Russia's massive, and leave the French army to just wander across Russia, and basically they have to stop when their food runs out, because in those days how you kept food fresh was you could smoke it or dry it or ferment it or pickle it, but people weren't sure that this was totally safe. It definitely didn't preserve the flavour, and it didn't preserve the nutrients, so a lot of people were dying of things like scurvy, lack of vitamin C. So Napoleon kept losing battles because of this problem, and in the end he offered 12,000 francs to the person who could work out how to keep food fresh. Step forward, somebody called Nicolas Appert. He wasn't a rich man. His dad was a wool comber, which doesn't sound like the sort of thing you have to be very well qualified for. Certainly Nicolas hadn't gone to school. He didn't know about bacteria or chemistry or biology, but he'd worked with food all his life. He owned a little sweet shop in Paris, and he became kind of obsessed with solving this problem. Basically, he just experimented for years and years and years. So first of all, he just put food into a jar and then tightened the lid really, really, really tightly. But the food still went mouldy. And eventually, after years, he cracked it. He put a lid on a jar very loosely. He put that into boiling water and then screwed the lid on really tightly, and the food inside stayed fresh for like months and months and months and months. Now, the funny thing is really that Nicolas and no one at the time had any idea why this worked. Now we know, in fact we're very aware at the moment, that in the air and on everything really are teeny tiny little microorganisms, bacteria. So if you just put food into a jar and put the lid on, then there's bacteria in the food and on the jar, and they live off the air that's still in the jar and make the food go mouldy. But if you heat up the jar, then the air particles inside get very hot, move apart from each other, eventually move out of the jar, and as we know from our air pressure lessons, if there's no air inside the jar and there's a lot of air on the outside of the jar, then this seals the jar really firmly shut. The atmosphere pushes down on the lid and no air can get in. Now, you might notice there is still a problem. There are little spores in food that can survive even if there's no air. So one of the really skillful things that Appert did after a lot of experimentation is to work out exactly how long food needed to be cooked for to kill even these little spores. The French Navy trialled his design on meat, fruit and milk, and the reviews were great. A very, very famous chef said, Monsieur Appert has discovered the art of fixing the seasons. Spring, summer and autumn exist in bottles. Appert's food, he said, recalls the month of May in the heart of winter. It is not an exaggeration to say that the small peas in particular are as green and tender as those that are eaten in season. I mean, now we just crack open a packet of frozen peas, don't we? And we don't think about it. But at the time, it was just incredible that you could eat food months and months or years after it had been picked. And it tasted just as good. So, needless to say, Appert won the 12,000 francs and he published a book called The Art of Preserving All Kinds of Animal and Vegetable Substances for many years. It probably sounded catchier in French, but it was immediately translated into other languages, caused a food revelation. People stopped getting ill from scurvy because canning preserves the nutrients in the food. So Appert started a business. He started a food bottling business. Unfortunately, he wasn't that great with money, and his factory was destroyed during the invasion of France in 1814. The government wouldn't give him any money to rebuild it. He'd spent a lot of his money trying to invent a can and not a jar that would preserve the food, but French tin wasn't very good quality, and he hadn't managed it. And like a lot of story time heroes, he died in poverty. Now, most people haven't heard of Appert because he called his new method appetization, which is a brilliant pun but did not stick because someone eventually invented a container made of tin. Canistra is Latin for a basket that you keep fruit in, so it was called a tin can. So the process started to be called canning. But if you look up who invented canning, you will still see Nicolas Appert's name. Just reading comments. Gluten-free flour is rubbish. Yeah, sorry, Kevin, I should have warned you. How come meat products in tins stay fresh and fruit does? Yeah, it all stays fresh, actually. I mean, these days canning isn't as popular now because it doesn't actually preserve the nutrients or the taste as well as freezing does. They didn't have freezing in those days. And also freezing not terribly practical for an army on the march either. Let's have a check on these tarts, bake-off style. I think... actually, they don't need that much longer. I'll give you a quick berry quiz and then we'll see. I think the jam tarts will be ready after that. Can you tell me which one of these is a berry? We've got raspberries, blackberries, banana, strawberries, cherries and a tomato. I will give you a clue. There are 2 berries on this board. Which ones of these are the berries? Oh. Shall I tell you? If you support me on Patreon and you've got your cookbook, you might remember this. So a fruit is something that grows from the ovary of a flowering plant. And if something is a berry, it has to have grown from a flower that only has one ovary. So let's start over here. Can you see that raspberries and blackberries have got lots, they're made up of lots of teeny tiny little bits. Each one of these bits grew from a separate ovary. So each one of those bits is a berry, but all together, raspberries and blackberries are not actually berries. They're called aggregate fruits. Strawberries, also not a berry for that reason. They grew from more than one ovary. But tomatoes are berries. A berry also has to have 3 layers. It's got to have a skin and a soft middle bit and a bit holding the seeds in the centre. So tomatoes fit that description, and bananas do as well, and watermelons as well. So cherries are encased, their seeds are encased in a very, very hard skin, so it's not a berry either, it's a drupe. It's like a peach or an olive or a plum. So there you go, there are 2 berries on this board in botany terms, and they are the banana and the tomato. Aaron, well done. You read my cookbook. I'm going to give them 5 more minutes. I just need to tell you why the horrible, strained out, seedy bits of my jam can teach us about the Milky Way galaxy. Look at that. Does anyone think that looks a bit like the spiral arms of the Milky Way galaxy? I think it's totally uncanny. One of the reasons the Milky Way has its long spiral arms is that it's spinning. It's spinning, you'll never guess this, at 168 miles per second. The Milky Way galaxy is spinning at 168 miles every second. It takes our solar system, our little sun, and all its planets about 225 million years to do one circuit. So we're about 2/3 of the way out on a spiral arm, just like that. So that is how my jammy little seeds can teach you about the Milky Way galaxy. It's results time. Oh. Yeah. She says, pretending that this is a first one and not a second one. Yeah, they're really good. We didn't develop too much gluten. The pastry's pretty flaky. Giving the flour particles their little waterproof coat really worked. And the jam hasn't bubbled over. Let's try the little experimental one, which isn't supposed to be very nice and it's supposed to be chewy. Totally fine. So the results are in. It turns out you can't really mix fat and sugar in a way that doesn't make them taste great. Thank you so much for joining me, you guys. That was really fun. I hope your jam tarts go well. I'll see you soon.